Hi, everyone. So welcome to my talk, Static Analysis Tool. Now you're playing with Power. Without further ado, this will be the agenda of this presentation. So we're going to talk about Static Analysis Tool. First, we're going to see some definition, just to get everybody on the same page. Some of you have already used some tool. Some of you don't know those, but maybe have experience with development. We're going to see what are the main motivation, the advantage of using those tools, the different level of sophistication, because not all tools are equal, what it's going to impact also their level of sophistication. We're going to look at the internals of tools. So this is going to be a bit of theory, but I'm trying to, for every concept, to do some demo. So this way, at the same time, it's going to be less abstract if you have not run a tool yet. And at the same time, you're going to learn some new tool possibly. So I'm going to go through a tool that scans Python code, Ruby code, Java code. That's it. And I'm going to close with additional consideration. So if you are planning to introduce code review or assisted code review with static analysis tool, I'm going to give you some guideline from my experience at using those and building process for those. So expect to do a C demo along this presentation. So who am I? My name is Philippe. I'm a researcher for GoSecure, and my main interest is on web application security, but I have also interest for other stuff, crypto, etc. Usually when I come here to talk, I select a specific vulnerability, some niche vulnerability that have recently come up, but I decided this year to select tool that I'm actually spending most of my time working on them. So I'm going to present one tool that I'm working on, which is Find Security Bugs, for which I'm working at GoSecure. So I'm a developer for Find Security Bugs, Security Guard, which is also a static analysis tool for .NET. I've also been multiple burp extensions, so maybe you have used any of those at some point. I'm also a contributor for the event NordSec. NordSec, it's an event similar to Hackfest in Montreal. So I've been developing CTF challenges, and this year I was a trainer for the conference. So definition. This won't be too long. So what do we mean by static analysis? This means we're going to analyze program, but without executing it. So if it's a web application or a binary, instead of running it and looking at it in debug, maybe with a debugger, we're just going to look at the source code. So think like a code review, but instead of being a human, then it's a script or an application that analyzes the code itself. And for this presentation, it's going to be static analysis, so analysis of code, but specifically for vulnerabilities. So just to let you know that you may find other static analysis tools that their focus is not security. So if you want to do security code review, some tool won't be effective for your need. That's it. So why do we want to use static analysis tool? The main advantage of this coverage, because there's going to be static tool, but also dynamic tool. So dynamic tool will be, for example, a dynamic scanner for example, a dynamic web scanner that you run to your website. So you give a few inputs to the scanner, like the URL. It will crawl the website. For every input it can find, it will do some tests with malicious payload. So this is a dynamic tool because the application is actually running, and the scanner is sending value to a live application. When we look at the static part of it, the main advantage will be the coverage, because if we have millions of lines of code, the scanner will often not be able to enumerate all the endpoints, and most application gets quite complex. If you have multi-step form, some form really need human interaction to reach some point, because otherwise an automated tool won't be able to guess some of the values. So that's one of the main advantage. Otherwise, quick discovery. So instead of waiting at the end of a deployment of an application, so we have done multiple iterations of development, instead of waiting for a pen test or a final audit at the end, a static tool can be run along the development, and you get notification for potential vulnerabilities. So that's a big advantage. Also, you get the vulnerability at the source. So a scanner will give you a symptom. So I insert a single code in this parameter, and it looks like there's an SQL injection, but it's just an external point of view. the statistical analysis tool will tell you at this line of code, this API is probably not used properly, and there's a potential SQL injection, or this API is probably not used in the right context here. So for a developer, it's interesting because he knows exactly where to look at in the source code. Limitation, I think there's not a specific technique that will cover everything. So the takeaway is not that statistical analysis tool will do everything, but if you combine a statistical analysis tool with dynamic one, you have a much better coverage because some vulnerabilities are easier to test and find in one of those techniques. So the conclusion, try to combine both. In statistical analysis tool, we'll get a lot of false positive because we made a lot of assumption. We're not running the application, so some value, we don't know where they come from. Is it coming from a config file? Is it coming from a user input? Is it a constant value that was initialized at some point in the program? We don't always know because applications are complex. Also, some vulnerabilities are not covered in statistical analysis tool. So misconfiguration, sometimes because you're scanning your web app, you won't see a configuration of your firewall or infrastructure, a misconfiguration. So if you have a S3 bucket that is exposed, you won't see this in your PHP or Java application. It will be more in deployment part that are usually not covered by a statistical analysis tool. CSR vulnerability, because it's more dynamic vulnerability and there's multi-layer to it, usually it won't be easy to find in source code directly, at least not automatically. And logic flaw, this is just something that most automate tool won't find because you require some human analysis, because you need to understand what is the business context of your application. So, okay, if I'm able to skip this step for a automate tool, unless we're talking about AI and we're not there, a tool won't be able to find this type of flaw. Just to say that there's going to be a good coverage, but to get a full coverage, usually if you combine multiple tools, then you'll get a better one. So I'm going to start with afterward with the most basic type of technique that tool I've implemented, and along we'll go with a more advanced concept. The most basic concept that tool can use is pattern matching. So think about grep. Some statistical analysis tool will actually just wrap grep with regex, or simply iterate to file and look one line by line individually to match specific API, for example. We're going to see that there's actually a big disadvantage will be the number of false positive, because we're not doing that much heuristic about eliminating potential false positive, because we're mostly flagging specific API without looking at parameter and context. Abstract syntax tree, this will be what most tools will do at least, which will transform the source code, the source file, to a model that is a structure that is easier to analyze to find specific method and specific API strongly without having super complex regex. The two last one, data flow analysis. This will be simulating the execution. So we can also say a symbolic execution for those two categories. The idea is that we're not running the code, but we're going to simulate the execution of code, and where's our dynamic input, we're going to take a symbol and take a guess about what the value could be. The last one is just an iteration over the data flow analysis. So you can do some analysis at the method level to see the data flow, but as soon as you do interprocedural, so between function, for this, the complexity explodes largely, and most tools won't do this. And if you see this, it's going to impact a lot the analysis time. So just if you have if you're a developer and at some point you have generate a UML diagram automatically, and you have dragged all the class of your application in one diagram, just seeing the dependencies would probably be impossible to read because there's too much dependency. Then imagine all the method call that you could see and would need to be simulated in a statistical analysis point of view. It gets really complex. So in general, the more we add complexity, the more the tool is smart. it's going to reduce false positive, but the analysis time will grow over time. In general, it won't be too much. So if you're doing a code review at the same time, it won't matter even if the tool takes 1 or 2 hours to run, because at the same time, you can check for a specific check like logic flaws, while the automate tool, which is pretty effective at finding, for example, SQL injection or XXC or misconfiguration, some specific things. Yeah, so obviously the fastest one will be pattern matching. So abstract and type tree. So before getting into the detail, I want to do a few demos. So the first one will be Bandit. So Bandit is a tool that is developed mainly by OpenStack team to analyze their own code. And Bandit at least do some AST of the code. So we're going to see a demo, not of necessarily AST, but of the tool Bandit. So if you're a Python developer, you might want to try later this tool. I think it will come back. Okay, so each time I do a demo, I will need to plug and unplug. So basically, I have, yeah, I'm going to zoom each time I write the comment. So I have, I'm going to use a demo project, which is django.nv. It's a company, Envisium, that has built basically a vulnerable application that contains vulnerability, so you can learn from those projects. I'm going to scan this project, so I'm going to zoom. I'll type the command first. So it's as simple as this. I'm using the command line integration, so just Bandit. I scan the parameter R is the root directory for the source code, so it's going to scan recursively to this folder. The output format will be HTML, and then the O is -O is simply the report name. So run this. Because the Bandit is mostly doing just AST, it's going to be pretty fast, so shouldn't take too much time. That's it. And then we have a HTML report that will highlight two types of vulnerabilities. So we have a command injection one and SQL injection. So we can see, for example, the SQL injection. It finds that in the file views.py, there's the execute method that receive queries. Then there's a string format that receive 3 parameters. And those parameters, if they are controlled by a user, this could lead to SQL injection. So yeah. And quickly, the fix for this would be to transform this to a prepare statement. So the idea is that a tool like this will eliminate some false positive, but you will still get a lot of them because there's no symbolic execution that is made. I have a small demo for this. So I'll just be targeting a different project. So same command, I'm just targeting a different folder, which is I'm going to show you the code first. Oops. So these are dummy sample. It's not a real application, but the idea is just to get a bad sample that will trigger some potential vulnerability. And if we look at the report, I'm going to open on the left the report. We can see that actually it's not I won't go for each sample into the detail, but the idea is that because it's pretty limited and it's only AST level, some things won't be covered, like, if we look at the safe variable, so if we have, let's say, 1,000 SQL queries in our application, sometimes for example, here we have constant value that are passed here, but because it doesn't simulate the execution and the transformation from a string format to a string, this will be a false positive for this case. Same thing in Bandit. If you assign a variable to, so here, for example, actually, here, it's doing some simplification. So here, I need to scroll on the left, but there's a condition, but in the end, it could potentially add a malicious input, but because it's a limited symbolic execution, it will consider that this one is a constant, but actually it's only one of the conditions that will be. Just to say that it's basically just doing inline level verification. But the idea is that you have tons of rules, and it will be more efficient than doing manual code review. Going back. Okay, so AST, how does it work? So basically, you'll have source file. The first step will be lexing. So the lexer will tokenize all your source files. So think about class name, function name, reserved keyword. And the next part will be transforming all those tokens to a structure. So in the end, the analyzer is not looking at plain text and line by line. It's going to navigate recursively through the tree and raise issue, for example, for looking just as a method call, for example, which was the case for a Bandit. The main feature, with AST, we won't have to do complex regex to support spaces, new line indentation, because we're going to actually parse the syntax of the language. We're going to have sometime type resolution. So if we want to match specific API on methods, this will be easier. For example, if we want to target the execute method of a specific class instead of just all methods that have the specific name. We can also add some heuristic, like I'm going to show in a moment. So this is just a high-level example of a syntax tree you could have. So this is a diagram from Roslyn API, which is just another AST. So when you analyze code in Roslyn, you'll have a top node that is compilation unit, which will be mostly every source file. In every source file, you can have one or multiple class. In every class, you can have one or multiple method, and et cetera, et cetera. For each method, you have parameter, and blocks will be code blocks. So depending on what you want to look at, you can navigate through the code structure and look precisely for types and a signature. An example of heuristic that will eliminate some false positives. So just with AST, we can find, if we look at this case here, it's a RSA crypto services provider. So this API will generate RSA key. Key under 1024 and less will be considered less secure than having at least a bigger key. So the idea is that we don't want to raise issue every time we see this API. Only if this value is 124 and less will raise issues. So here, when you're going to parse the syntax tree, we're going to look for object creation, matching the specific class name RSA crypto services provider. And in the argument of this creation, we can look at the argument, and we'll have a literal value that will be this int 1024. So this works because for API like this, in general, the developer will put the value inline or hard-code it. But there's many API that will typically be variable that are assigned and then used. So it will be harder for AST to find those. But the idea is that the AST is a basic building, but we can do more looking at the AST. So what can we do more with just the structure? We're going to start to look at simulating the execution. So this will be, again, with the objective of eliminating false positive. So symbolic execution, we're going to do this for two reasons. Propagate state. For example, we saw previously we were looking for a key size. So if we initialize a key size, we want to trace the value until it's being used. But we also might want to look at how to reach specific conditions. So for example, in C++, it's really popular to look at use symbolic execution to find how to reach a specific code path automatically. So how can we define how to reach this condition? This is symbolic execution. So symbolic execution is the idea that instead of having real value, like at runtime, we're replacing value with symbol. So we have a pseudocode on the left. Input, this is not a constant value. It's just something we're going to keep and transform and build on top of it. So I have an example next, step-by-step of this code. The idea is also to, once we want to target a specific condition, we're going to transform this to a mathematical equation and try to solve it. So this is really theoretical. In practice, there's many mathematical functions that cannot be resolved. There's also multiple functions that depend on I/O. So it's not always feasible. So here, for this specific function, we can resolve that if we want to reach the true cases, we can transpose this to, in the end, we need input 2 multiplied by 2 minus 1 to be bigger than 2 to reach this specific condition. Very simple example. I'm going to do step by step just to show you that symbolic execution, if we want to support all conditional statement, we're going to need to make a state eval for all our variable. And for each condition, we're going to fork a different path. So we're going to see the state going to multiply each time a condition is reached. So for example, we have first 2 input assigned to 2 variables. The second one is multiplied by 2. So at this point, it's always the state is always the last line. We can see that we have 3 variables in our state. Then to reach to do the code path when the condition is true, we're creating a fork for this specific condition. And then would probably be closing the code for this specific method by doing the condition to be true. But we also need to do the path for when the condition is false, and this would create a different code path and different symbol in the end. So symbolic execution is often associated with taint analysis. So taint analysis is closely related. So taint analysis will cover tracking encoding of values, because in security, sometimes you need to either sanitize value or encode them properly for the context. So we're not just going to track a symbol, but we're also going to track state of each value. So what are we targeting with taint analysis? So we have pseudocode on the left would be a safe case where we have 2 constant value being concatenated and passed to a query language, a query API, I mean. And on the left, we have concatenation, but it contains a user input. And there, we need to transfer the state. And at the point where we're going to analyze the apply filter, we need to be able to reach the point where C is as the tainted state. So quickly, if we do the symbolic execution, we assign user ID to A, then we assign to B a user input. So at this point, B is considered taint. So if we look at the table, we see that we have 2 variables initialized. And then if we do the concatenation of both, at this point, we need to consider that C contains a taint variable or is influenced by one, and as a result will be also tainted. So in practice, taintness, it's much more complex than but not that complex, but there's not just taint and not tainted. In fine security bugs, just to give you a specific example for the tool I'm going to demo, tainted will be any value that is known to be unsafe. So if there are API that are recognized to be user input, these will be flagged as tainted. Unknown will be a state that we apply to any variable that is coming from external method that we don't know. Safe will be a variable that has been sanitized. So for example, if you have a string that you cast to an int, at the point where it's an int, it can be passed to any query language, we'll be pretty sure that there's no injection possible. Constant will be hard code values. So if we do, we have a lot of conditions, but in the end, we're just concatenating constant string. There won't be a potential exploitation, for example, for SQL injection, if it's always a combination of constant value. So those are the 4 basic states in fine security bugs, but we have also another concept of tags, where variable will be tracked and there will be state related to specific context. So if you encode value for XSS, so encode use specific API that are encoding specifically for this context, they will be tagged as XSS safe. If you decode them, the tag will be removed. But the idea is that we don't want to, when a value is escaped with SQL API and return in HTML, to be considered as safe, because it's not the right context. Every context should have a specific encoding. Demo time. So I wanted to do a demo that have a lot of interesting difference. So for this one, I'm going to demo static analysis, but on a binary. So just to show you that static analysis doesn't apply only when you have source code. So here we're going to take a vulnerable Android application. I'm going to use a few tools, APK tool to extract Android manifest. So if you are doing manual analysis, you might want to look at entry point like activity. It's also going to extract in a Smalley version this sample code. But the main command we need to use to do a static analysis will be dex to jar, which will be converting the classes.dex to a jar file. And then fine security bugs will be able to scan this jar and output a report of vulnerability. So I'm going to try this. Okay, so I've already prepared, I've already unzipped the APK. So I'm using Insecure Bank V2. So it's a vulnerable application, so I'm not taking a commercial application. You can find this project if you want to learn about mobile security for Android platform. This is a good application because it's a working application. It's not just a code sample. You can run it, install it, audit the code, also do dynamic analysis. But we're going to do just a static scan to it. So I have unzipped the APK. So this will be the content of APK unzip, where we're going to see the classes.dex. And in APK tool, I also have extract the Android manifest in the other folder. So I need to zoom out to just remember the command. So again, the target will be the classes.dex that have been actually already converted to classes dex to jar after running the dex jar command. So this takes 30 seconds, but it's not that interesting. And I'm going to copy to go faster like this. And next, so I'm running here fine security bugs with just a few argument progress because it's going to take more time than the previous tool. The output format is HTML, just the file name of the report, so it's really similar to the command we saw previously. The target will need to be a jar, so it's not a Java file, or you need to have the compile form. And I'm gonna, so the report you'll get will reference to class and method, but if it's not compiled in debug, you won't get a line of code. But it will be precise enough because, for example, if it's a potential, there's going to be a lot of informational stuff. So, for example, if WebView have JavaScript enabled, it will flag you in this method, in this activity. But with a disassembler, a decompiler, I mean, you'll be able to quickly navigate as if it would be in an IDE. So I'm going to open disassembler, decompiler. Okay, I should have saved the pre-generate report, but in the end, okay, I'm just going to show the code. So one thing to remember, when APK are built, you're going to see the code of your application, but also all the dependencies of the application. So if you see in the potential issue package name that are not from your code, you can decide to look at it, but mostly you're going to do a code audit on a Google API of Android, or looking at specific components. So we're going to see in the report a few false positives. Here, okay. Again, it's an HTML report. It has, by the way, integration with Android Studio. So if you want to have a better experience at navigating through the issue, there's a plugin for spot bugs that will integrate to Android Studio. So I'm just going to take two issues to show you some example. So here, it found that there's a, I'm going to zoom just to be sure everybody can read. So in this class, crypto class, method AES256 encrypt, it found that the IV is not properly initialized. So we don't have the source code because it was analyzing bytecode, and reading the bytecode would be hard to read, but we can simply jump to the class, looking at the package name, here, crypto class. We find this method. Here, there's a IV parameter spec, which will receive as a parameter a byte array that is the IV for the encryption. So here, it couldn't find a random generation that was secure. So if we just trace back where this method is used, do a quick search, we can see that it's being used here, and the value of IV byte higher is coming from this field, and here we can see that the developer, so I need to pass an IV, it needs to be an array of this size, I'm going to initialize it to 000. So obviously, this is bad for crypto because the first block will be have confidentiality issue potentially. We can also see that at the same time that the key was also hard-coded. This would be flagged in another issue. But the idea is that if you have APK, you'll have tons of code to analyze if you didn't develop it yourself. And static analysis tool can save you some time because you will scan at the same time the main code and also the libraries that are bundled with the APK. So you gain some efficiency. And there's also, I'm going to show you a few others type of issue that it can find. Broadcast events. So broadcast events are event intent that are sent in Android between applications. So if you don't have the proper permission applied, you'll be potentially able to intercept them from a malicious application. So if we just look at one example here, it's the broadcast intent could be received by a malicious application. We're going to look at the class where it was found from the method broadcast change password SMS. Sounds interesting. it's the first method. And already we can see that every time the user will change his password, it's going to broadcast an event with his phone number and his new password. So this could be information leakage if the permissions are not set correctly in the manifest. So that's it for this demo. Yeah. And by the way, Fine Security Bugs work on bytecode, so you'll be able to scan Android application, but also Java web application, Kotlin application, and Groovy application Scala also. Symbolic execution. The reason I present Fine Security Bugs is because we're doing intent analysis and symbolic execution for every method. That's why the tool took a bit longer to scan this application. Here, there are a few problems with symbolic execution, or at least limitation, where not all false positive will be limited because there's a lot of things that we don't know in a static mode. So here, just to do a summary of what I'm trying to show up, there's the second method that has a signature of SQL injection. But the thing is that there's another method that receives an int that will convert the int automatically to a string. So we could say, okay, the method in our code is only calling the first function, so it won't be vulnerable because since it's an int, we cannot do any malicious payload from it. The thing is that sometimes when we're scanning code, we don't know if we are scanning everything. Sometimes we might miss code that are coming from libraries or external components. Also, the code may be subject to change, so at some point, the second method might be called directly from new code. So for this reason, depending on the tool, some will decide to maybe say it's a false positive because all code path passed by the first method, but some tool will decide, okay, we're going to still flag them. So there's a lot of complexity that comes to doing symbolic execution across different methods. Yeah, so the big question when we're analyzing this code and we're trying to automatically confirm if it's a vulnerability is the second one called directly somewhere else that we didn't see? Other big thing that will be a big obstacle for static analysis, reflection. So you might think that this method is only called at these 4 places, but there are a lot of components that do reflection. So sometimes it will be implicit that some methods are called. Framework do a lot of reflections, or sometimes setter method will be called automatically. So a lot of things can happen. Dependency injection. So to do some abstraction between components, you'll sometimes make a public interface. So your service will implement an interface, and you have potentially multiple implementation. So if you scan your code, what is telling you that you have seen all the implementation of this specific interface? Maybe at runtime, once the application is deployed, something was missing, and there's another component that is vulnerable, for example. Second order vulnerability. So we're doing symbolic execution and tracking down user input. But what if the user input is saved to a database and then used later? Because most transactional websites, for example, if you're on a store and you add to your cart something and you order finally your cart, not everything will be made at the moment where you click order. So usually it's going to be sent to a queue, and eventually the event will be processed. So because there's a lot of queues and delay, it's harder for static analysis tool to see that this specific value was actually a user input somewhere down the line. Encapsulation. So static analysis tool make big effort at identifying API. So there are standard API in every language to do all kind of stuff, parsing XML, SQL stuff. But the thing is that developer will wrap those API in a library for more efficiency. It's not a bad practice, but for static analysis tool, it's making it harder to see those API because it will flag only potentially the wrap API. And if somebody is doing a triage, for example, and marking, this case is only used at those places, and I know it's safe, it will mark it as a false positive, but at some point, the encapsulate API might be used wrongly in another context. So this happens a lot in frameworks. Last component, continuous integration. This is a step. This is not related to code internals, tools internal, but more a concept that you can add to gain more efficiency. If you have a development team that is pushing a lot of code, you don't want to wait at the last minute to do code review. So for this part, I'm going to do a demo with Brakeman. If you're doing a Ruby application or more specifically a Rail application, this is a pretty good tool to do automate analysis. So demo time. Up. Okay, the application I'm going to analyze is called Railgoat. Zoom. Railgoat is, I think it's an West project, but I'm not sure. So again, pretty simple, the command. So we just need to specify the scope. So here dot is representing the current folder, and dot -o is the output report, and Brakeman, just looking at the extension, will decide that this will be the format. So you can export to .html, .json, .xml also. So pretty quick. It's a small application. So again, I'm going to show you the report. I quickly just to show you how does it look. So you'll have a summary of the different type of vulnerability that it found, and you can also look at each of individually each issue and see the code that is potentially weak or vulnerable. So the reason I'm showing Brakeman is because there are some easy integration to continuous integration. So I'm going to show in a moment how you can also integrate this tool to have higher level feature. So this was just a quick demo to show the tool as its most basic form. So continuous integration, just to get a definition, this will be in development, not just a concept for security, but just the process of merging all your artifacts to build your application. So the most basic form is simply compiling your application. If you're building automatically your application on a server, you are doing CI. You can also add tasks to this, so you can also, after the compilation is done, run tests and do code analysis. And we're here to talk about code analysis. So the idea is that you could use a statistical analysis tool for security and integrate them to your builds. And most tools have integration already, or sometimes some scripts are needed to just glue some component and produce the report you want. So I'm showing how you can evaluate, make your process evolve to the point where you have continuous integration. So the most basic form will be just starting doing code review. If you are not doing code review in general, just implementing the process would be a first step. Then you can analyze different tools and find one that is efficient, then integrate it to your process. So you would have triage of vulnerability coming from a tool and manual code review. And you can add to this, finally, the continuous integration would be to run this tool continuously and potentially generate report and notification to developers. So it's not, one is not replacing another, it's simply a component adding to another. The second demo I want to do for Brakeman is to show you how simple it can be to do a continuous integration configuration. So for this one, I'm going to show you how to configure Jenkins to run a Brakeman. I'm going to zoom in a moment. So here I have a Jenkins installation that has one pre-configured build. So it's actually scanning the same code that I showed previously, Railgo project, but here I have done 3 simple configuration. So the first step I want to configure is the source. So it will fetch the code from this repository I have configured. So here it's a public repo from GitHub. The most important step is the Brakeman scan. So pretty much the same. The only difference I'm doing is I'm exporting to the JSON format, which will be analyzed by the Jenkins plugin. I'm adding a pipe true, just because Brakeman by default will return a return code that is not 0 if it has at least 1 issue. But here I want to successfully return, and otherwise it won't run the post build operation. And the post build operation, I needed to install a plugin for this, but this is thanks. This is in the store for Jenkins, so it's not that complicated to install. And by default, it will look for Brakeman output the JSON, so make sure you have this. And how does it look? Going back to the project. So once it's scanned, I get an overview like this of all my vulnerabilities. So it's the same result, but displayed in a web interface. So one of the advantages of using Jenkins, first, it runs automatically. So the developer doesn't need to install a tool, make sure it's configured with the proper rule set. Also, it's easier if you're opening issue on a bug tracker to point to a URL that are static rather than, oh, come to my desktop. I'm going to show you in my IDE on my, or just in my report on my desktop. So it's easier to share. At some point, actually, Jenkins will clear the build results, but make sure you are exporting all the detail to your issue tracker. But yeah. I'm going to go quickly because I only have 5 minutes left. Yeah. Just as reference to how quickly it can be to deploy a Jenkins if you have not already, as reference, a simple example for Brakeman. A bonus I wanted to add, I'm developing an extension for Roslyn for .NET application. There's an interesting concept with Roslyn is that you can identify vulnerability that will be displayed in Visual Studio. So this is one example that is not a security bug, but just to show you the basic integration. But you can also build refactor code fixes, that will do refactoring task. So instead of just finding the issue, you can also be creative and do automatic fix for specific bugs. So you will have analyzer that will analyze the AST tree, the abstract syntax tree, but you will have refactoring task that will manipulate this abstract syntax tree to, in the end, propose code fixes. Final, I'm done with the technical stuff related and demos. I want to give you some feedback at integrating a static analysis tool to your process. So the first thing is you cannot just really blindly select a tool and say, this black box, I'm going to use it and I'm going to send it to the developer. You first need to make sure that it's actually going to find what you need. So if you're using a specific framework, specific API, make sure that it's going to find the bugs that you want. Otherwise, it will be a false impression of security. So to test tool or compare them, there are high-level criteria that have been built by the West project that is listed on top. And there are multiple code projects that will provide you sample. So it can be can give you some pointer about how can you compare tools to evaluate them, how efficient they are, because some tool might run pretty quick, but they might have not that much rule. And so make sure your framework and specific library are covered. Also, there are tools that are existing, so make sure if you want to be creative and you don't want to buy a commercial tool, because also commercial tools are an option. If you want to decide to customize a tool, commercial or public. It's like any development project. You're gonna have some complexities, so there's maintenance associated to it. If you can reuse as much as possible, so for example, if you're building a Python application, why not build Analyzer built on top of Bandit, for example, rather than starting your own project? So reuse as much as possible. And custom rule, like any code, there's complexity to it. So if somebody in your team is building tons of rules, but nobody is able to maintain them, can be a problem. And finally, I'm done. So I'm giving some reference. So all the tools I have demoed in this presentation will be in the slide that will be public. And I have some other links that will follow. So thanks for coming to my presentation. Any question? Yeah. Yes, so SonarCube was mentioned. So SonarCube is both, they have their own analyzer, but it's also a platform. It's similar to Jenkins, but with additional stuff that I didn't present. So you'll be able to plug in as Sonar has many plugins. So I don't know what you want to talk about. SonarLint. Okay, so SonarLint is an analyzer, for example, for Java to run inside IDE or inside SonarCube. SonarCube is also an interesting component because you can add a state to your bugs. So, for example, if you have a big project, millions of lines of code, you might have hundreds of issues that will be flagged at the first scan. If you are doing project, you don't want to revisit every issue every time you do a scan. So SonarCube can highlight the new issue that were introduced by specific commit or specific iteration. So that's something to look for. Don't just look at result from a specific scan. Try to see if there's incremental report and feature like this. Any other question? So have a great conference. Thanks.